Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for exam P. Batteries A and B have lifetimes that are independent and exponentially distributed with a common mean of m years. The probability that battery B outlasts battery A by more than 1 year is 0.33. Calculate m. Let us write x for the random future lifetime of battery A and y for the random future lifetime of battery B. Then we know that the density of x is 1 over m times e to the minus x over m, because the mean of the distribution is m, and the hazard rate is 1 over the mean, or 1 over m. And of course, the density is only positive for x greater than 0. It's 0 otherwise. And the same density for y, just we use y instead of x. Because x and y are independent, their joint density is a product of the two, which is 1 over m squared times e to the minus the quantity x plus y divided by m. And we are given that the probability that y is greater than x plus y is 0.33. Our job is to find m. Well, okay, let's figure out that probability that y is more than x plus 1 from what we know about the density. And that probability will be the integral over the region where y is greater than x plus 1 of the joint density. So it would be the integral from 0 to plus infinity, values of x running from 0 to plus infinity, and then y running from x plus 1 to infinity. So more than x plus y of the joint density. A double integral like that. Okay, so we take the terms that involve only y, and what we have under the integral for y from x plus 1 to plus infinity is 1 over m times e to the minus y over m dy. That is actually exactly the probability that y is more than x plus 1, where x is the specific value of big X, which must be the survival function of y evaluated at x plus 1. What is the survival function of exponential distribution? Well, it's always e to the minus the hazard rate times the variable. The hazard rate is 1 over m, so in this case it will be e to the minus the value of the random variable, which is x plus 1, divided by m. So e to the minus x plus 1 over m is that integral in parentheses, while we put out the terms involving x in front of it, so it's 1 over m times e to the minus x over m. So we calculated this integral, and now we have the integral from 0 to plus infinity of 1 over m times e to the minus x over m times e to the minus x plus 1, quantity x plus 1 over m. We can factor out that e to the minus 1 over m, and what is left then is e to the minus 2x over m, which is the same as e to the minus x over 1 half m. Okay, so if we put 1 over 1 half m in front of it, then that becomes a density of exponential distribution with mean 1 half m. So if we take the integral from 0 to plus infinity of 1 over 1 half m times e to the minus x over 1 half m dx, that is the integral of a density of exponential distribution with mean 1 half m, and integral of density has to be 1. But to have that 1 half m there, we have to also multiply the whole thing by 1 half to make sure that we didn't change the value. So this whole thing is equal to 1 half e to the minus 1 over m. Therefore, 1 half e to the minus 1 over m is equal to 0.33, or e to the minus 1 over m is 0.66, or minus 1 over m is natural logarithm of 0.66, so that m must be equal to minus 1 over natural logarithm of 0.66, which is approximately 2.40664941. So we actually know that answer is E. It's an interesting thing to point out that you don't even actually have to calculate any integrals to do this thing, because you can find the probability of y being more than x plus 1 by writing it as the probability that y is more than x plus 1 intersection of that event with y being more than x. And of course, if y is more than x plus 1, then it's more than x. So this is true because the first set is a subset of the second. So the intersection is just the first set. And then we write this as the probability that y is more than x plus 1, given that y is more than x, times the probability that y is more than x. And that first probability has to be the same as probability that y is more than 1 by Memoryless property of the exponential distribution. Remember that it works this way, that an exponential distribution is waiting time until something happens. If you waited before, and you kind of restarting the count, you wait for as long as before. The waiting time in the future doesn't depend on what happened in the past. That's what is called a Memoryless property of the exponential distribution. And the probability that y is more than x, well, it has to be the same as probability that x is more than y, because they have the same probability distribution, they're independent. And if you take the probability of y more than x plus probability that x more than y plus probability that x is equal to y, you must get 1, because these are all possibilities that can happen. But the probability that x is equal to y is 0, because that happens along a line, and the probability of hitting a line for a continuous distribution is 0. So this has to be e to the minus 1 over m, which is the probability that y is more than 1, times 1/2, or 1/2 e to the minus 1 over m, which is what we got before, the same thing. Anyway, so we solved this for the value of m, and we got answer E. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.